In this video, we're going to look at a few examples where we're going to graph the sine or cosine function. Now, if you recall the previous videos that we did, we looked at the standard basic sine and cosine graph and what that shape should look like. And so let's say we're given either y equals a sine of x, a cosine bx minus c plus d, or a sine bx minus c plus d. Recall that these letters have some meaning for us when we do our graphs. So for instance, the absolute value of a, that's going to be our amplitude, right? And then we have 2 pi over the absolute value of b. That's going to be your period, right? The period of the graph. And then we have your phase shift. And recall that the phase shift, that's going to be the starting point of your graph. And sometimes you may hear of the phase shift as your horizontal shift. Okay, and so that's going to be c over b. And then the last thing is your midline, right? And so your midline, that's going to be the line y equals d. And this is just going to be the middle of your graph, okay? So let's look at a few examples with graphing these functions. And so when I start this, I always suggest to students, before you dive in, see if you can identify your A, B, and your C's, those type of things, right? So you will compare your function to the standard function and then identify what is A. So for us, A is going to be the absolute value. The amplitude is going to be the absolute value. Oh, there we go. The amplitude is going to be the absolute value of A. And that's why we use the absolute value, because you can have a negative value. And so if you recall, the absolute value of -2, that's going to be 2. So what this means for us is whatever our midline is, the graph is going to have a height of 2 from the midline and a depth of 2 from the midline. Okay? So we keep that in mind as we go. Now, we're going to look at what the period is. Okay? So the period, that's going to be 2 pi over b, right? And so, we didn't do what I said. What is A? So here A is -2. And then B, now this, we can rewrite this function. It looks crazy here, but we can actually rewrite this to be -2 times sine of pi over 2 x, right? So we can separate the x from our coefficient, because remember, that's going to determine what b is for us. So this is going to be your b. So b is going to be 2 pi over, your period. Oh no, b is not 2 pi. B is pi over 2. I was thinking about our period. Sorry about that. So yes. So b is going to be pi over 2. And then we can now look at our phase shift. But before we look at that, C, notice that there is nothing there. So C is 0 for us in this question. And then lastly, there is no D. So D is also equal to 0. All right, so with this information, we can just plug in. Our period is 2 pi over b. And we like to say the absolute value of b because you could have a negative sign there. But in this case, it's positive. So it would just be 2 pi over b, or in this case, 2 pi over pi over 2. Okay. And so if we were to simplify this, remember now we're dividing a whole, you can look at it as a whole number, by a fraction. So my students like to say keep, change, flip. So you keep your numerator, you change this division sign to multiplication, and then you flip your fraction here, which is going to now be 2 divided by pi. Right? We can put this 2 pi over 1. We cancel what's common, our pi. So this is telling us that the period for this function is going to be 4. So what that means is we're going to have a length. So let's kind of fill these things in as we go, right? So this tells us that if we are to graph this function, that means my function is going to have a length of 4, but maybe not 4. We need to know where the starting point is first. But the entire graph, recall that we talked about sine being a periodic function. So that means the first period is going to be within 4 units of whatever our graph is. But we'll look at that. Now, we can look at what our starting point is. That's going to be helpful. Or starting point, or let's just say it's the phase shift. I like to call it the starting point, but it's the same thing. So the phase shift, that's going to be your starting point where the graph is going to start. And recall that's going to be given by C over B. And so in this instance, C is 0 divided by pi over 2. And that's going to be 0. So, well, we're starting at 0. So that means that our length is indeed 4, because if you want to know the full length of your graph, you'll do 4 plus 0, and you'll see that the full length is going to end at 4. Okay? So we're going to end at 4 here. All right, so now we need to determine our midline. And so the midline, recall, that's going to be what? Y equals D. That's my midline, which in this case means we're going to have the midline at y equals 0 or the x-axis. So the x-axis is serving as my midline. Maybe a highlighter will help. Okay, that's my midline. Now recall the amplitude represents the height from the midline to the top of the graph. So I have a height of 2, so that's going to be 2, and I have a depth of 2, so my lowest point is going to be -2. Now, we know what the sine graph should look like, right? Originally, the sine graph, you'll have a 1 here and a -1 here. If you recall, we'll have pi over 4, pi over 2, and I'm just recalling the recalling what we've done before. So we start at 0, pi over 2, pi, 3 pi over 2, and 2 pi. So this is where we started. And if you recall, when we did it before, right? If not, you might want to watch the previous video that we did. Okay, so let me try to erase this. There we go. Here we go. Not quite, right? Let's try this one more time. Okay, better. Alrighty. So when we start at 0, we go up to the highest point, then we go to 0, then back to the lowest point, and then back up. So this is what our graph for sine should look like. Now, there is one thing that will help when you're doing a graph like this, the partitions. And I like to put in my partitions so that I can know my equal distance between each point for the graph. So here, to find your partition, it's going to be your length of your graph. And so from here, my length of my graph, essentially it's going to be your period minus the starting point. That's going to tell you the length, right? And then you're going to divide that by 4 because you want it in 4 equal parts. So for us, our period is 4 minus our starting point of 0, and we're going to divide that by 4. So this is going to be 4 divided by 4. So I have a partition of 1. So that means I can write 1, and then to get to the next one, I'll add 1, which is going to be 2. Then I'll add another one, which will be 3. And then I'll end at the period for the graph. And so now I know what my graph should look like. I start at 0. Then I go up to the highest point, right? And then I go down to 0, and I go back down to the lowest point, and then go up to 4. Now, this would be a perfect graph if we were doing y equals 2 sine of pi over 2x. Now, for us, we have a negative value, right? If you recall in A, we have a negative number. So when we think about a negative number, when it deals with your function, if you have negative of your function, what that means is we're going to flip the function, right? So this graph that I have here currently is really for f of x equals 2 sine pi over 2x. So if we want to know what the graph of negative 2 sine pi over 2x looks like, we're going to have to flip this graph or reflect it about the x-axis. So I'm going to reflect it down. Okay. And so instead of going to the highest point, I'm going to go to the lowest point, and then I'm going to go up to 0. Then I'm going to go up to the highest point and back down to 4. And so the black line is going to represent this graph. Y equals, let me put this on the other side. Y equals negative. Okay, so if we may, we can actually delete this because that's not the question we had. So this is the graph that we want. Okay, this is going to be your f of x equals negative 2 sine of pi over 2x. Okay, so if you have a negative value, that's going to impact your graph. All right, let's look at another example here. All right, what if we had this function, 3 sine of pi over 4x minus pi over 4. So like I said before, it is going to be very helpful if we identify your, A, B, C, and D's. So for us, A, for this question, A is 3. B is pi over 4. C is also pi over 4. D, we don't have any D, so D is going to be 0. Alrighty, so our amplitude is going to be what? The absolute value of 3, or just 3. Our period, what's that going to be? That's going to be 2 pi over whatever B is. And for us, B is pi over 4, so it's going to be 2 pi divided by pi over 4, right? Or we can do our change flip, so it's going to be 2 pi times 4 divided by pi. If I put a 1 here, I cancel my pi's. Okay, so my period is going to be 8. All right, then I'm going to look for my phase shift. Okay, phase shift. All right, so my phase shift is going to be what? My C over B. And then this question, C is pi over 4. And my B, C is pi over 4. And B is also pi over 4. So it looks like my phase shift, since you're dividing pi over 4 by itself, it's 1, because any number divided by itself is 1. Next, I want to identify my midline. And what is that going to be? Well, it's going to be y equals d, which is y equals 0. So again, the x-axis is going to be my midline. And okay, now that we have our midline, let's look at our endpoint. So if we want to determine what the endpoint is, we're going to add or phase shift or starting point. So your phase shift. You do your phase shift plus your period or the ending point. So your period. So this will tell us where the graph should end. So for instance, our phase shift is 1 plus your period, which is 8. So this means the graph is going to end at 9. And we start at 1, right? The graph is going to end at 9 and we start at 1. Now, the partitions, let me just say this, you don't have to do the partitions, but I find that the partitions are very helpful. So to find your partition, you would do your ending point minus your starting point divided by 4, because you want to put it in 4 equal parts. And if you wanted to do 8 equal parts, you would divide by 8. All right, so my ending point, that's 9, minus my starting point. So, whoops. So again, ideally what we're trying to do is to partition this graph into 4 equal parts. And so we're going to take the length of the graph and divide it by 4. All right, and so this becomes 8 divided by 4. So my partitions are 2. So if I want to find the first point is going to be 1. And then next, we're going to do what? 1 plus 2 is going to be my second point, which is going to be 3. And then my third point is going to be 3 plus 2. So you're going to be adding increments of 2. It's going to be 5. Okay, and then my other point is going to be 5 plus 2, which is 7. And if you always want to check, you can do 7 plus 2 or your final point, and it should give you the end point that you had, which was 9. So since our amplitude is 3, so again, our midline happens to be 0. So we're here. That's my midline. Okay, so I'm going to be 3 units above my midline. That's the height of my graph. And then 3 units below is the depth or the lowest point. Okay, so this would be -3 and this would be 3. Okay, so now I just do what my sine graph should do. We start at 0, we go up to the highest point, then we come back down to 0, down to the lowest point, and then we're back up. And that would be my graph. Okay? Okay, so now we're going to look at another example with cosine. And so we want to graph y equals -2 cosine pi over 2 plus pi plus 3. So as per usual, we're going to first identify our A, B, C, and D. So A is going to be -2. B, that's going to be pi over 2. Now C, be very careful here, right? Recall the original form is y equals A cosine bx. Here important, we usually have minus C, and then plus D, right? But in this case, we have a plus sign. So we can actually rewrite this as y equals -2 cosine pi over 2 minus negative pi plus 3. And so here is where you'll get that plus. So the reason why we rewrote it is so that we can see that our C is actually negative pi. Okay, so sometimes you can look at this and you can say, well, based on the formula, we just take the opposite of what's there. Here, when it was minus C, we just took C as is. Here it's plus C, so we take negative C. Okay, and so our D, that's going to be 3. So let's identify the important parts of our graph. Okay, so A, or amplitude rather, our amplitude, that's going to be the absolute value of negative 2, right? Because that's your A, or that's going to be equal to 2. All right, now our period for this graph. So the period is going to be equal to 2 pi over B. And in this instance, well, the absolute value of B, of course, it's going to be what? 2 pi over pi over 2. And yes, we're going to do or keep change flip. So you keep your numerator as 2 pi. You change that division sign to multiplication. So now this becomes 2 divided by pi. And so we will cancel. And here we have 2 times 2, which is 4. So my period is 4. Next, I'm going to find this phase shift. See if this graph shifted any. Okay. So our phase shift, that's going to be C divided by B. And so that means my phase shift, C divided by B. Well, C is negative pi divided by B is going to be pi over 2. Or this is going to be negative pi times 2 divided by pi. And so if I cancel my pi's, right, you can always put your wholes over 1. This becomes negative 2. But what is important here is to note that our phase shift is also known as your horizontal shift, right? And so this is telling us that we have an horizontal shift of negative 2. But when we talk about horizontal shifts, I always say it goes opposite your intuition. So if negative 2 is your horizontal shift, we're actually going to go 2 units to the right, but we'll look at that shortly. All right, next we want to identify our midline, right? Where is our midline? So our midline, recall that's going to be y equals d. And so for us, that's y equals 3. Now, again, you do not have to do this, but I strongly suggest identifying your partitions. And so here, our partition, well, that's going to be your end point. I don't believe we calculated the end point. So let's find the end point as well. And so our end point, well, that's going to be, yes, our end point. Well, that's going to be your starting point plus your periods. It's going to be negative 2 plus 4, right? Your starting point plus your period. Actually, we don't know our starting point, right? Because we're shifting 2 units to the right. Okay, so let's not worry about that right now. But if we can. So if we originally started at 0 with the original cosine graph, if we recall the cosine graph, right? This is our original cosine graph. We start at 1, and then you have 4 partitions here. Okay, so you start at 1, you go down to your lowest point, back up, And so you're usually starting at 0. So if this is saying we are shifting our graph 2 units to the right, we're no longer starting at 0, but we're going to be starting at 2. So this implies that our starting point is actually positive 2, right? You're going to shift your graph 2 units to the right. Okay? This means we're shifting 2 units to the right. Okay? Now we can actually calculate our endpoint. So if we're shifting 2 units to the right, well, that means my starting point is actually 2 plus my period. So my ending point is actually going to be 6. All right. So now that we have our endpoint, which is 6, and we have our starting point, we can do our partitions. Okay. Now, if we want to identify the partitions are going to be so we're going to have what? Our endpoint minus our starting point divided by 4, because we want 4 equal parts. So our endpoint, we said, is 6. Our starting point is 2 divided by 4. That's going to be 4 divided by 4. So I have partitions of 1. Okay. Now let's try to put this all together. Okay. All right. So I'm going to have to do quite a bit of shifting left and right. All right. So the first thing I'm going to graph is my midline. Okay. My midline is very important because from there I can determine how high my graph is going to be. So my midline, we identified that's going to be y equals d, which is y equals 3. Alrighty, so that means my graph is shifted up. Your midline also tells you your vertical shift. So my graph is shifted up 3 units. And so instead of 0 being my midline, here is my midline at y equals 3. Very good. Now, based on the midline, I'm going to look at my amplitude. My amplitude was 2. So it means that my graph is going to be 2 units above and 2 units below my midline. So let's go over and see here. So 2 units below, that means, okay, I'm going to be at 1 for my minimum and 2 units above. So recall this is 3. So 2 units above is going to be here at 5. So that's going to be the highest point of my graph. So far, so good. We also identified that this graph, the phase shift was -2. So that means we go 2 units to the right. So it means this graph is starting at 2. So we're going to be starting at 2. And we said we're ending at 6. So I'm starting here, 3, 4, 5. And I'm ending here. Well, we can calculate the partitions. Okay, so here it would be 2 plus 1, which is 3. That's the first point. Then the second would be 3 plus 1, which would be 4. Then I would be 4 plus 1 as my third point, which is 5. And then my final point, my fourth point, would be 5 plus 1, which is where I should end, right? Which is 6. So my partitions are the points I'm going to have into play here is going to be 3, 4, 5, and 6. Okay. Alrighty. So now we can graph. But one thing I want us to note here, the graph A was actually a negative value. So recall, this is my original cosine function. So if it were that my function was y equals 2 cosine, right, and everything else, then the graph would have started at my highest point of 5, and then I would, actually, I'm not starting at 0. It would have started at my highest point of 5, right? And then I would come down to my midline at 3, then down to the bottom, back up, and then I would be like so. But that is not the graph, right? In fact, it's a negative. So what does that mean? If it's a negative, what that means is my graph is actually going to be flipped upside down. And so I'm actually, instead of starting at the top of my graph, I'm going to be starting at the bottom, right? And so my graph is now flipped. So I'm going to be here, then I'm going to go up to my midline, then up to the top, coming back down, and like so. Okay, so this black would represent the graph that I'm looking for, which is f of x, or y, equals -2 cosine pi over 2 x plus pi plus 3.